Good evening, everyone. Welcome to the demo session on STAADPRO Structure Design Manual and ETABS. A quick announcement before starting the session. A link will be put in chat box at the end of the class. So after the session, if you would like to join the course, you can register using that link and get a discount of rupees 150 off on the actual course price. The link will be valid only till 2 p.m. tomorrow. Now, without any further delay, I would like to welcome Akhil sir to start the session. Thank you.
Good evening, everybody. So this is a demo session or introductory session about this course we are going to launch. The title is Methods for Manual Analysis, STAADPRO and ETABS. So the thing is that, direct going for a designing course or a software course without clearing your basics, that is futile. So what we are trying to do in this course is that we have tailored this course in a way that first we are going to clear your basics. If your basics are already clear, fine, you are going to strengthen them here. And if not, you are getting another chance to clear your basics from third semesters and up to fifth semesters. Basically, we have integrated strength of materials and structure analysis, volume 1, when we are talking about manual methods for manual analysis. And then we are moving on to STAADPRO as well as on ETABS. So without further ado, let's start. So objective for this course is to make you more certain about the basics of theory of structures, right? Theory of structures, that what exactly a structure is and how exactly a structure mechanics of structures work. We are trying to cover this up in this course to make you proficient in manual methods of structure analysis, because the thing is that no matter how good you are in a particular designing software, you need to check your results. You need to compare notes with your manual methods, right? Without that, you can't be sure whether your design is correct or not. So that is it. Then to make you confident in modeling and analysis using STAADPRO as well as ETABS. What are the prerequisites for this course? This course is that students attending this course should be at least aware of the basic knowledge of mechanics. Moving on. So the course content for first and second week, we are going to first and second week we try to cover these points in as detailed as possible, which covers bending moment, shear force, fixed beams, then moment distribution method. Moment distribution, we choose this particular method because that is the most commonly used method, where and not just commonly used, it is comparatively easy to follow this method, and that will give you comparatively accurate answer. If you are comparing it with the slope deflection method or any conjugate beam method or any other method, that will give you and another thing is that with this method, when in my experience, if you are talking about slope deflection method, that is a very good method and it's comparatively easy method. But for a beam, for a continuous beam or for a beam, if we are moving onto a portal frame or something like that, something complicated, that method start becoming tedious. Well, moment distribution method the degree of tediousness for this method that stays same, whether you are doing a single beam, a continuous beam, or a portal frame, single story portal frame, double story portal frame, single bay portal frame, or double bay portal frame. It's like that. Then comes building frames. In building frames, we are going to introduce substitute frame method, and again we are going to include calculation of lateral forces on a building frame. Next, second and third week. In second and third week, we are going to target on STAADPRO. So introduction and understanding the STAADPRO way of doing the job, creating geometry using different tools and methods, of course, how to model. Then after this wireframe model, you need to define cross sections for actual analysis. So defining sections of structural elements, defining constants, specifications, and supports. By defining these things, constants, specifications, supports, you can make sure that the structure, the frame you are modeling right now in a software can be, you can replicate the frame here as close as to the actual construction. Then comes introduction to wind and seismic loads, defining load systems in STAADPRO. So that is for second and third week. Then fourth week, from fourth week onwards, we are going to target ETABS. So for ETABS, overview of the modeling process, the overall modeling process, terminology, then load cases, static load cases, automated lateral load cases, and load combinations. And these points cover a modeling process as well as analysis process of this particular software. So that concludes our course content. Now for introduction right now, let's introduction to basics. So applied mechanics, if we are going for applied mechanics, so most important thing is force, right? When an external force is there, then the whole mechanics things develop. Without force, there is no need to get into the mechanics. So what is exactly is a force? Force is defined as an agent which produces or tends to produce, destroys or tends to destroy motion. Now in that case, when we are talking about structure analysis, the motion is the state of body, whether it's moving or it's stationary, that doesn't matter right now. That is a state of body. If it's in a stationary position and due to some force it starts moving in a certain on a certain axis, that is also interesting to us. And if it's moving already and by applying certain force you are transferring this body into a stationary body, that is also of our interest. So that is a force. Then comes resultant force. If a number of forces P, Q, R, etc. are acting simultaneously on a particle, then a single force which will produce the same effects as that of all the given force is known as a resultant force. So when we are talking about a structure, a beam, for example, and there are forces acting, there are more than one forces acting on that particular beam. What we are trying to do, what we are trying to achieve when we are talking about I am going to analyze this beam, what exactly we are doing? What we are trying to do is we are trying to find out the deformation, the stresses going to develop in this section due to all these forces. So in order to do that, what we are going to do, we are going to analyze any change in your element due to any one force, and then we are going to find out what these force cumulatively going to do to this beam. So that is why we have to find out resultant force. That is resultant force. If a number of forces P, Q, R, etc. are acting simultaneously on a particle, then a single force which will produce the same effects as that of all the given forces is known as resultant force. Then moment of a force. Now, what exactly force do? If, for example, there is a beam of section L, length L, and on that particular beam at a certain point, let's say on the very center of that span L, a force F is acting. Now, what exactly this force is going to do? Definitely, if we are talking about beam, that beam is going to be supported on its both ends, most probably, right? Then what is going to happen, because due to this force is going to act on that particular point where it is acting at that particular section. So that will give you shear force. And then if this particular force, due to this particular force, what are the changes going to happen to the whole span? So how you are going to get that? That is called moment of a force. So it is the turning effect produced by a force in a body in which it acts. That is what we call moment of a force. So whenever a force is acting, that force is producing. When we are talking about a beam, a flexural member, that force is going to produce two things. One is moment of a force, and another is shear force. Okay, let me try it once more. Force अगर कोई बॉडी मूव कर रहा है, if a body is moving in a certain direction, और आपने उस बॉडी के मूवमेंट को रोक दिया, that means आपने उसके ऊपर एक्सटर्नल फोर्स अप्लाई किया है, ठीक है। अगर कोई बॉडी स्टेशनरी पोजीशन में, वो स्थिर खड़ा हुआ है, और आपने उस पर एक्सटर्नल फोर्स अप्लाई करके उसको किसी पर सर्टेन एक्सिस के ऊपर मूव करना शुरू कर दिया, तो भी आपने फोर्स अप्लाई किया है। जैसे ही फोर्स का इनिशिएशन होता है, जैसे ही फोर्स इंक्लूड होता है किसी भी बॉडी के आसपास, वहां पर मैकेनिक्स आ जाती है। मैकेनिक्स आते ही अगर वो मैकेनिक्स इज फॉर अ सिंगल बॉडी, किसी एक बॉडी के लिए, अगर वो फ्रेम है या कोई बिल्डिंग फ्रेम है या किसी भी तरह की फ्रेम है, एमएस की है, कंक्रीट की है, तो हम नाउ वी आर टॉकिंग अबाउट स्ट्रक्चर्स, ठीक है ना, थ्योरी ऑफ स्ट्रक्चर्स। तो ये तो हो गया फोर्स। दूसरी बात मैं ये कह रहा था कि फोर्स के केस में जब जहां भी फोर्स अप्लाई करता है, ठीक है, फोर्स किसी सर्टेन पॉइंट पे अप्लाई करता है, या हो सकता है फोर्स यूडीएल, तो बिकॉज ऑफ दैट फोर्स, अगर आप उस पर्टिकुलर सेक्शन पे उस फोर्स के असर को यू आर स्टडीइंग, देन इट इज कॉल्ड शियर फोर्स, ठीक है। वो इफेक्ट उस सर्टेन सेक्शन पे जहां पर फोर्स अप्लाई हो रहा है, वो इफेक्ट कहलाता है, वो इफेक्ट प्रोड्यूस करता है शियर फोर्स। और अगर मैं उस सर्टेन सेक्शन से एक्स डिस्टेंस इन किसी भी डायरेक्शन में एक्स डिस्टेंस पे मैं अगर उस सर्टेन सेक्शन से उसका इफेक्ट, उस पर्टिकुलर फोर्स का इफेक्ट कैलकुलेट करने की कोशिश करूं, तो वो चीज कहलाती है मोमेंट। तो जब शियर फोर्स की बात करते हैं, दैट इज जस्ट फोर्स, प्योर फोर्स। मोमेंट में फोर्स इनटू डिस्टेंस, जिस डिस्टेंस पे मैं उसका जो एप्लीकेशन है, वहां से जितना डिस्टेंस पे मैं उसका इफेक्ट आई एम ट्राइंग टू फाइंड आउट, तो दैट विल गिव मी, वो डिस्टेंस को मैं उस फोर्स में मल्टीप्लाई करूंगा एंड देन आई एम गोइंग टू गेट मोमेंट, ठीक है। Moving on. Now, equations of equilibrium of any system of force. ये तीन conditions है. These three conditions are submission of H, all the horizontal forces, submission of all the horizontal forces on this particular particle has to be 0. Same, all the vertical forces has to be 0, and submission of all the moments has to be 0. Submission H is equal to 0, submission V is equal to 0, submission M is equal to 0. अगर ये तीनों conditions, these are called conditions of equations of equilibrium. अगर ये इक्वेशन है किसी भी पर्टिकुलर पार्टिकल, तो वो पार्टिकल प्योर रेस्ट में है, योर स्टेशनरी फॉर्म, ठीक है ना, अगर ये कंडीशंस को अगर सेटिस्फाई हो रही है तो, ठीक है। मूविंग ऑन, नाउ फोर्स लगाने से, आफ्टर अप्लाइंग फोर्स, ठीक है, व्हाट इज गोइंग टू हैपन, उस फोर्स की वजह से व्हाट इज गोइंग टू हैपन इनसाइड दिस पर्टिकुलर एलिमेंट, उस एलिमेंट के अंदर क्या होगा, जैसे ही फोर्स लगेगा उस एलिमेंट के अंदर उस फोर्स को रेजिस्ट करने के लिए stresses are going to develop, ठीक है। That is what we call stress. What exactly is the definition is? Stress is the resistance to deformation per unit area due to the action of external force. जैसे ही external force apply किया, उसके reaction में आपको उस particular element, उस particular body के अंदर stresses develop होंगे. Expression for that is small p is equal to capital P upon capital A. Small p is definitely it is stress, capital P is external force and capital A is area, ठीक है ना, unit area. So वो जो external force है वो कितना area पे act कर रहा है, ये भी depend करता है stresses कितनी develop होगी उस पे. Magnitude और intensity of stresses develops upon the force acting, the external force, as well as the area on which this external force is acting. Next is strain. Now because of this stress, वो stress जो है वो उसको resist कर रही है, उस external force को, that stress is resisting. But after certain limit, if pressure is वो अगर increase होता जाता है, जो external force है, it is constantly increasing, तो after certain time it is going to overcome the stresses. Body का एक up to certain limit, this particular element, it can't produce more stresses, right? When it this external force is going to overcome the stresses, there is going to be strain. जैसे ही वो external force stress की value से आगे बढ़ेगा, आपका जो element है उसके अंदर strain develop होने लगेगा. Strain is the deformation per unit length. Strain is the deformation per unit length. Then comes elasticity. I'm sure you all know what elasticity is, but still, as an engineer, elasticity is the property. Elasticity is the property by virtue of which a deformed body springs back to its original position. Elasticity is the property by virtue of which a deformed body springs back to its original position after removing the external force. Simple example है, अगर एक rubber band को, if you are pulling onto a rubber band, it is going to stretch, and as soon as you are going to release it, any of its end, it is going to come back to its original position. That is what elasticity is. But in a rubber band, you can see elasticity, it is more elastic. But when we are talking about a column, a concrete column, RCC column, there is some amount of elasticity in it. ठीक है ना? For engineer, there is some amount of elasticity in it. For a layman, अगर आप पूछोगे, no, of course no. But for an engineer, there is some certain amount of elasticity in that particular RCC section. So that is how, that is what interests us. This elasticity is present in each and every material. Next, moving on. Now, due to all this stress, this external force, this stress, what is going to happen? Deformation of a body. And how we are going to define it? The expression for that is delta L is equal to PL upon AE. P upon A is what? Stress. So stress into L upon E. Now what is delta L? Delta L is deformation of a body, is equal to P, external force, L is length on which this length of the body, upon area of cross section, upon E. E is, what is E? Modulus of elasticity. So moving on, this is deformation of a body. Next is modulus of section. Modulus of section is the quantity obtained by dividing the moment of inertia by of a body about its center of gravity. First, you have to take moment of inertia. You have to calculate moment of inertia of the body in question around its center of gravity by the distance of the extreme fiber from the centroidal axis and is denoted by Z. Modulus of section is denoted by Z, and it is defined as moment of inertia about the center of gravity by the distance of extreme fiber from the centroidal axis. That is called modulus section. And this particular property is very important when it comes to design, and especially when if you are more involved in steel designing. This is important in all kinds of structures. I am not saying that when we are talking about RCC, modulus section is not important. No, it is always important. But if you are going for MS steel design, you will use this particular property more. Modulus section का use वहाँ पर ज़्यादा होता है. Then comes types of structures. Types of structures. Yeah, you have any question? Who is raising your hand? Who is raising their hand? Please go on. So now types of structure. When we are talking about types of structure, first is statically determinate structure. Statically determinate structures. Now, what is statically determinate structure? If you are going to analyze a certain structure, आप किसी structure को analyze कर रहे हो, और जो analysis में, if you are using these equations, you have to use equations of equilibrium, ठीक है ना? And just by using this equation, आप उसको analyze कर लेते हो, then it's called statically determinate structure. The definition says, if the forces in the members of a structure as well as its reaction can be found by the conditions of equilibrium or the principle of statics alone, it is known as a statically determinate structure. Then comes statically indeterminate structure. The thing is that if these forces, if the forces in the members of a structure as well as its reaction cannot be found out by the conditions of equilibrium, agar wo conditions of equilibrium are not enough to analyze this particular structure, then it is known as statically indeterminate structure or redundant structure. उस केस में क्या होता है? You have to create new equations in order to solve this particular structure. Now, this statically indeterminate structure, it is again divided into internally indeterminate structure and externally indeterminate structure. Okay? These are the types of structure, which is first statically determinate structure, जो कि you can say that it is, it is idealization of this particular structure, right? In practical, it's very hard to find a statically determinate structures, right? So they are all, most of all, they are statically indeterminate structure. And then this statically indeterminate structure, it is again divided into internally indeterminate structure and externally indeterminate structure. Chaliye, moving on. Now we are talking about supports. Structure ho gaya, now supports. So whenever you are going to analyze any element, let's take a beam. You have to analyze a particular beam. You have to keep in mind what are the end conditions of this particular beam. Uske ends par kya connection, right? That is very important. That is what we call support. Same is for column, same is for any structural element. So what type of supports do we have? First is movable hinge support, then immovable hinge support, then fixed support, just like that. So movable hinge support is in which a section can move can translate, as well as it can rotate. That is called movable hinge support or roller support. This is what that support is. You can see that because of this roller, it can move in this particular axis to and fro, and it can rotate. So that is roller support or movable hinge support. Then comes immovable hinge support. When we are talking about immovable hinge support, it can only rotate. There is a hinge here, so it can rotate, but it cannot translate. It cannot move to and fro. So now in this case, it can move in horizontal plane. You can see that. It can rotate also, but it cannot move in vertical plane. So if you are obstructing, अगर आप vertical plane में इसको किसी भी दिशा में इसका movement रोक रहे हैं, there is going to be a reaction for that. ठीक है ना? There is going to be a reaction for that. If you are obstructing its movement in vertical direction, there is going to be a reaction in vertical direction. Talking about pin support, what is happening? Rotation is fine. It can rotate, but what it cannot do, it cannot move in to and fro in horizontal direction as well as in vertical direction. So there are going to be two reactions. हमने दोनों axis पे इसका translation obstruct किया है. तो जैसे ही आपने उसी movement को obstruct किया, that means you are applying something externally on that particular body. So there is going to be a reaction. So now we have two reactions when we are talking about pin support. Lastly, we have fixed support. What is fixed support? Fixed support में horizontal or vertical movement to obstruct है, we are also obstructing the rotation. And if you are because of obstructing horizontal and vertical support, there are two reactions, and now you are obstructing rotation, so there is going to be a moment. Is direction में rotation, we are obstructing it, so there is going to be a moment in opposite direction. So that is what a fixed support is. Next is, after supports, now comes bending moment and shear force. So bending moment and shear force, what exactly is bending? First of all, what exactly is bending? Bending implies deformation of a bar produced by loads perpendicular to its axis. So that is bending. Bending when we are talking about strength of materials. But when we are talking about structures, that becomes bending becomes flexion. Okay? When we are talking about structures, for example, in a structure, beams and slabs, they are flexural members. Why they are flexural members? Because they are going to resist the external load over them, over these sections by the virtue of flexion. They are going to flex. They are going to bend. ठीक है ना? They are going to flex, and by this flexing, they are going to resist this external force. So, but when we are talking about right now, we are not in structures, we are in strength of materials. So in strength of materials, it's called plane bending. ठीक है ना? Bending is not just for civil engineers. Bending is also for mechanical engineers. So that is what we call bending. Now, what bending is? Bending implies deformation of a bar produced by loads perpendicular to its axis. There is plane bending as well as oblique bending. What is plane bending? If the plane of loading does not passes through one of the principal centroidal axis of inertia of the cross section of the beam, the bending is said to be plane or direct. If the plane of loading does not passes through one of the principal centroidal axis, sorry, there is a typing mistake. If the plane of bending passes through one of the principal centroidal axis, x or y axis में से कोई सा भी एक axis coincide कर रहा है with the plane of loading, right? In that case, the bending is going to be plane bending or direct bending. And if that is not the case, agar plane of loading is not coinciding with any of the principal axis, x या y axis के साथ वो coincide नहीं कर रहा है, in that case the bending is said to be oblique. Moving on. Now, अभी shear force or bending moment, if you have to calculate shear force or bending moment, if you have to draw a diagram for shear force or bending moment, you need to know there are these are established types of beams. We have all the data available about these beams. So what are these beams? Types of beams. First is cantilever beam. There you can see, I'm sure you all know, this is a cantilever beam, this is a free end, and this is a fixed end. Now, force is acting on this end. Nothing is going to happen to this end. Because of this force, whether it's at this point or at this point, इस force का जो असर होगा, जो reactions होंगे because of this action, that is going to happen on the fixed end. ठीक है ना? That is what we called a cantilever beam. Then comes a simply supported beam. This is our simply supported beam. There is a roller support, there is pin support. This is how you express a simply supported beam. जरूरी नहीं है एक तरफ roller support हो, it can be pin support on both ends. When we are talking about RCC, frame, the intermediate beams, they are like this, but they can rotate, but they cannot translate. ठीक है ना? So you can imagine that there is a pin support on both its ends, not a roller support, unless you are providing a special arrangement for that. So that is what we call a simply supported beam. Now, as you can see, what is going to happen here? It can rotate, but it cannot translate. At this end, it can rotate as well as it translates. Lastly, we have fixed beams. In fixed beams, on both ends, neither it can translate nor it can rotate. And mostly we have to deal with this particular type of beam, fixed beam, and cantilever as well. Moving on. Now we have to talk about STAADPRO. What exactly STAADPRO is? It's a general introduction. You all know what STAADPRO is. STAADPRO is a designing software. It is a computer-aided designing software, but you have to be clear in your mind that STAADPRO is not AutoCAD. STAADPRO, ETABS, कोई सा भी designing software हो, that is not AutoCAD, because AutoCAD is not a designing software, it's a drafting software. ठीक है ना? AutoCAD is a drafting software. Anyone can learn AutoCAD and work on it. No problem there. You don't have to be engineer for that. ठीक है ना? कोई भी, whether it's a normal graduate or someone who is not even a graduate, आप उसके ऊपर you have to practice on that, on AutoCAD I am talking about, and you can work on AutoCAD, no problem there. But when you are talking about STAADPRO, ETABS, SAP, TECLA, all these software, you have to be an engineer for that. ठीक है ना? You are not just drafting a line. आप एक rectangle नहीं बना रहे. You are designing something. So whatever answer your software is providing you, you have to have the capability to cross-check these answers. And how you are going to do that? First of all, you have to be engineer, and then you have to be proficient in manual design and analysis method. उसी से आप उसको cross check कर सकते हैं, ठीक है ना? So what STAADPRO is? STAADPRO is a tool for structural engineers. It is stands for Structural Analysis and Design. That is the full form of this acronym. STAAD is one of the first software applications in world automating the work of structural engineers and liberating them from lengthy and tedious manual methods, hence enhancing their efficiency and boosting the construction industry altogether. ठीक है? What exactly? The STAAD is in India. STAAD comes first in India. It is the first of the designing softwares which comes to India. and it was very popular back in the day. Back in the day, it was very popular. Still, if you are working for government, you, as far as my experience says, that you need to, you need to be aware of STAAD. But private sectors, in private sector, things are changing. Private sector is, of course, more adapting than a government sector. So in private sector, when we are talking about high-rise buildings, frame structures, ETABS is taking over STAAD. Okay? ETABS is taking over STAAD. So that is, but if you have to design, if you are not into frame designs, if you are into bridge designs, if you are then baki everything else, you can't do all these things on ETABS, not yet. Okay, for that you have to go to STAAD or the mother software of ETABS, which is SAP 2000. So STAAD is more of a general design software, while ETABS is, it is specifically for frame structures. Moving on now, ETABS. ETABS is a special purpose analysis and design program developed specifically for building systems. That is what I was telling you. It's sophisticated yet easy to use. If you are asking me, I find interface of ETABS, more accommodating than interface of STAAD. Now, what is ETABS? What is the full form of ETABS? ETABS stands for Extended Three-Dimensional Analysis of Building Systems. Extended Three-Dimensional Analysis of Building Systems. This is just for your knowledge. Now, in ETABS, in ETABS, model definition is floor by floor, then column by column, bay by bay, and wall by wall, instead of nondescript nodes and elements in general purpose programs. Now, the thing is that in this course, we are going to teach you ETABS as well as STAAD. So there is, you don't have to compare it. But the thing is that this is how ETABS work. ETABS don't work on nodes and the connection between these nodes. It works, as I told you, the model is defined by floor by floor, column by column, and bay by bay basis. This makes structural definition simple, concise, and meaningful. Next, in most buildings, the dimensions of the members are large in relation to the bay widths and story heights. Those dimensions have a significant effect on the stiffness of the frame. This is a very important point. These large dimensions, they have significant effect on the stiffness of the overall frame. ETABS corrects for such effects in the formulation of the member stiffness. Unlike most general purpose programs that work on centerline to centerline dimensions. Okay? Then ETABS is a completely integrated system. This means that you can create only one model of the floor systems and the vertical and lateral framing system to analyze and design the entire building. Now this particular statement, okay, fine, it's an integrated system. It is just there. Okay? The integrated modules include drafting module for model generation. For model generation, you have to use drafting module. Then seismic and wind load generation module. Okay? You have to apply lateral loads in a frame structure. When we are talking about high-rise building, wind load and seismic is always important, but when we are talking about high-rise building, wind load takes more significance. Then gravity load distribution module, finite element based linear static and dynamic analysis module, output display and report generation module, steel frame design module, concrete frame design module, composite beam design module, steel joists design module, and shear wall design module. These, now the thing is, frankly speaking, you can get all these in STAAD as well. But if you are going by the market in present scenario, if you are going to work for private sector, you have to be aware of ETABS. This concludes our introductory demo session. Now, if you guys have any question, please go on. Okay, you want me to go through course content once more, right? Let's do it. So this is the course content for first and second week. We are going to cover these topics, which is manual, bending moments and shear force, fixed beams, moment distribution method, building frames, and there are some minor topics which I'm going to include in order to understand all this. Next, in second and third week, then we are going to go for STAAD, introduction and understanding the STAADPRO way of doing the job, creating geometry using different tools and methods, defining cross sections of structural elements, defining constants, specifications and supports, introduction to wind and seismic loads, and defining load systems in STAADPRO. And after this, we are going to move to analysis. Then comes fourth week and onwards. Then from fourth week and onwards, we are going to emphasize on ETABS only. So overview of the modeling process, terminology, static load cases, automated lateral loads, load combinations, and then comes analysis. So this is the course content for this specific course. Now, if you guys have any question, please go on. Seismic load is going to be included. I told you seismic load will be there. Automated lateral loads. What is lateral load? That is seismic load and wind loads, right? Devesh, for that you have to talk to Protrainy people. Just discuss this point with them, and they will let you know. You know. Sohail, foundation design is not the part of this course. Okay, this is all about analysis. But when you are doing, when we are going to, when we are doing, when we are covering these softwares, it will be there. Frame ka design, if you are going for frame design, definitely beam ka or column ka design is going to be there. But we are not going to emphasize on design. And if we are talking about foundation design, generally, I don't think STAAD is a good software for foundation design, as well as ETABS. For foundation design, there is a state foundation, a separate software, and there is for ETABS comes from CSI, and there is a software for there is a software there. I'm for SAFE. Thank you. SAFE is there for that. What about SAP? SAP is not the part of this course, right? They ask you to raise the question with me. Okay, then let me discuss it with them, and then then they can answer you back. Okay, it's not complete course. Okay, fine. Anybody else? Okay, so okay, we will discuss about your suggestion for sure. Okay, then let's conclude. this lecture. Thank you all.
Just a quick announcement before concluding. So as mentioned previously, a registration link is put in the chat box. So registering using that link, you can avail ₹150 off on the actual course price. And the link will be valid only till 2 p.m. tomorrow. Thank you.
Okay. Good night, everybody.